What you're about to see is top secret. Do not tell my mother.
Any of these look like the symbols you saw?
Where did you get these?
Archaeologists found these unexplained markings in ancient ruins all over the world.
They gotta mean something, like a message or like a map.
Hey guys, welcome to another rendition of chemistry. We're jumping into Unit 12, which is all about acids and bases. This is Coach Miller.
And Mr. Bunting.
And we're going to walk you through how to identify and how to name acids and bases. So this really should be a review, right, Mr. Bunting?
It looks very familiar, Coach Miller.
Yeah, I think I remember this from when we were naming compounds, but we're just going to look at acids and bases specifically. First thing, if the acid ends with IDE, or if the anion ends in IDE, so we're looking at the negative ion of the compound. If it ends in IDE, meaning it's just hydrogen and one other element ending in IDE, we will call the acid hydro, give it that prefix, and then have the ending IC, so hydroic acid. Another thing to look for is if the anion ends in ATE. So now we're looking for a polyatomic ion. So we've got hydrogen bonded to some type of polyatomic ion ending in ATE, then no hydro prefix, but the ic still stays there as for our acid. And lastly, if the polyatomic ion ends in ITE, then the acid name will have OUS in it. The best way to do this is to just jump into a couple of examples. So why don't we do that?
Well, how do I know an acid is an acid? How do I know I'm looking at an acid when I see a chemical formula?
That's a good question. And you know, if hydrogen is the first element, I believe, is that what we're looking for?
I believe so. Hydro means hydrogen, right?
Yep.
Right.
So anything with hydrogen in the front, we're probably dealing with an acid.
Okay, awesome.
At least for this class. So HBr, definitely hydrogen in front. Br is the anion bromine or bromide. Would be ending in IDE. So I look at my rule, and if it ends in IDE, I'm going to go with hydro as my prefix and keep the stem, which is brom, hydrobromic acid.
Normally you leave out the dashes.
Yeah, we can just put it all together. But I understand what we're doing there. We're just showing the prefix, showing the stem, and showing the suffix. Awesome. So next example, sulfuric acid doesn't have hydro in front, but it ends in IC, so I know that the polyatomic ion ended with what?
Well, if we look back up at our rules, we see that anything that ends in ic without the hydro has to have an anion that ends in ATE.
Cool. So on the back of my periodic table, I could find that polyatomic ion, right?
Right.
And looking on the back of my periodic table, I see that that is sulfate.
We knew it was sulfate from the prefix SULF.
Yep.
So something that had SULF and ended with ATE would be sulfate.
Right.
It's all a big puzzle.
So now, how do I write the formula? I know what the polyatomic ion is. So isn't there something to do with charges here?
Yeah, well, we already know since it says acid that hydrogen is going to be our first element. We know that's going to have a +1 charge, like always.
Okay.
So what would the charge of sulfate be?
Well, on the back of my chart, I look and sulfate always has a -2 charge.
All right, so we can crisscross those charges. We would get H2SO4.
Awesome. So I need 2 hydrogens to balance out the charge of 1 sulfate.
Right.
Cool. Well, I think that we should at least do one more, maybe that ends in OUS, and then let the guys or let the students run with it.
All right, yeah, they can use some practice too.
So HNO2, I know NO3 is nitrate, so I'm thinking that NO2 is probably nitrite.
Nitrite is right.
And anything that ends in ITE, I know my rule, it must end in OUS when I'm naming the acid. So nitrous acid.
That's easy enough.
That one's pretty easy. Awesome. So here, students, if you guys want to go ahead and pause it, we're going to...
Gross.
That was being mean. All right, so now that we have acids under our belt, we can look at bases, and bases are actually, I think, a little easier
Oh yeah, very much so.
because it's really you just name the positive ion or the cation, and then call it hydroxide, right?
Mm-hmm. That's what OH is.
So everything OH is going to be hydroxide, and I'll go ahead and write these in. How about that?
All right.
So the cation is Na, and I look on my periodic table, Na is sodium. So I know sodium's a +1, and I know that hydroxide is always a -1. So when I put these together, I'll just need one of each. And we just call it,
Name the cation, name the anion. Sodium hydroxide.
that's pretty easy.
Oh, this next one looks a little bit tougher.
So aluminum, group 13 metal, I know it's a +3. Hydroxide's a -1. And I know that hydroxide has to stay together, so OH is going to be in parentheses, right?
That looks about right, because you got to keep all those OHs as one entity.
So if I crisscross the charges, I know that aluminum will be a +3. Hydroxide's a -1. Got to keep them all together. AlOH3, and just name the positive ion, and name the negative ion. All right. I think we're good there. We just need to make sure that our charges balance and make sure that we keep hydroxide in parentheses, and then we'll let the students run with the next three.
All right. Should be pretty simple.
So go ahead and pause it here. You can work these next three out. We'll write the answers for you and come back and check your work. Well, so far this acid-base stuff seems more like a review than a new unit to me, Mr. Bunting.
Mm-hmm. So far.
But we need to talk about maybe some of the properties, I'm guessing, of acids and bases.
Yeah.
So how, obviously we're not going to be tasting these things in the lab.
Yeah, it's not a good idea.
We may be able to feel them, but we'd at least need to know what we're dealing with here. So an acid, when an acid tastes, I'm trying to think of some common acids that we come in contact with.
Would be like a citrus fruit. Would those be pretty acidy?
Yeah.
Those
So
taste kinda
citric acid.
Citric acid would be kind of a
So I'm going to go with sour.
sour. It's a good descriptive term.
And a base would be I don't know, maybe like Alka-Seltzer or something.
Alka-Seltzer, so kind of bitter, kind of
Yeah.
chalky.
Nasty.
Mm.
I don't think that's a word that we'll use there, but bitter will work. So feel, acid, I don't know that acids really have a feel other than they feel a lot like water.
Get some of that grapefruit on your hands. Does it feel like a whole lot different than water?
But bases, I know we often use bases in like cleaners and stuff, right?
Mm-hmm.
And kind of slippery or... And reaction with metals. Which one of these things are going to react with metals?
Well, we can do the dissociation reaction, so the single displacement reactions, and we could see that reacting an acid with a metal will produce hydrogen gas.
Okay,
We saw
so-
that in lab once, didn't we?
That's right. I think we did that.
Some zinc and hydrochloric acid, and then we
Oh yeah, I remember that.
then we popped it. Huh.
So yes, and they produce okay, and bases,
Bases don't seem to do much.
electrical conductivity. And know we're going to get into this when we start talking about electrolytes and stuff like that. But acids definitely break apart in water, right?
Mm-hmm.
So, yes. And bases, I think bases do the same thing, do they
Yeah,
not?
I think so. These are both ionic bonds, right?
So bases will break up in water and they'll give you ions, and so they're both going to have electroconductivity, yes. Litmus paper, now we're back to elementary science here, I think.
Mm-hmm.
Litmus paper, I remember acids were always red.
Mm-hmm.
Let's do this. Just to get a little visual.
Color change. I like
red.
it. And in all caps. It's kind of important to throw it in red.
So acids are red, and bases start with B, and it'll help us to remember that bases are blue when litmus is involved.
Acids are red, bases are blue. I
Awesome.
like chemistry. How about you?
And that's a great rhyme. Maybe they'll remember that. pH. So we're dealing with actually a value here. So the pH of an acid, I remember from my previous science classes, anything less than 7, right?
Mm-hmm.
So less than 7.
6.9 all the way down to 0.
So 0 to 6.9. Awesome.
Less than 7 is the best way to remember that, though.
And bases, obviously, will be anything greater than 7. So 7.1 all the way up to...
14.
How high does it go?
I believe it goes up to 14.
That's right. So the pH scale goes to 14. So
What-
7.1.
What about that 6.9 to 7.1? What's in there? Just nothing? Or what would have a pH of 7?
Well, if something has a pH of 7, then that's directly in the middle, which I would call neutral.
Neutral. Ah.
And I think the thing that we come in contact with most often that's neutral is water. Is that right?
Yeah, that's right. It's good to know.
Awesome.
Good to know.
So water's in the middle at a pH of 7. We'll get into that. Stop
Well,
here.
see you later.
Look at this place! I feel smarter already. Can you smell it?
Yeah, it smells like $40,000 a year.